All right, those of you that were absent today or were late or missed part of the notes, this video is to get you caught up with Objective 1. We just have a couple of examples to update from our notes from last week. It's the same set of notes. We're still in Objective 1, so I don't have to put a title on my paper and I don't have to put a question off to the side. We are simply just picking back up where we left off last week as if we were still in class, still taking notes. So, our first example, we have a girl delivering newspapers, and we want to find her delivery rate per hour. So, we know that Jada can deliver 189 newspapers every 3 hours. Okay, so I just set up the rate like that, 189 newspapers in 3 hours. So we want the unit rate, or the constant of proportionality, means the same thing. So we need to figure out how many newspapers she can deliver in 1 hour. So in order to do that, we're doing the same thing we were doing last week. Everything follows that same equation, k equals y divided by x. So we already have it set up here. So what we want to do, to get from 3 hours to 1 hour, we divide by 3. 3 divided by 3 gives us 1. Whatever we do to the denominator, we also want to do to the numerator. So we have to divide 189 by 3. Top number goes in, bottom number goes out. So 3 will not go into 1, but it will go into 18 6 times. 6 times 3 is 18. We subtract, nothing left. Then we bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. Subtract, we have nothing left over. So we can say that she can deliver 63 newspapers in 1 hour. That is our unit rate. That is our constant. Okay? So before we get into our next example, we're going to write down some helpful hints that will help you going further, knowing what is the x value, what is the y value, and how do I set this information up. Okay, so one helpful hint is anytime we have an amount of money in our problem, that is always going to be our numerator. So for us, that is going to be our y value, because y always goes on top. Anytime we have a measurement of time, whether it is minutes, seconds, days, hours, weeks, months, any measurement of time, that is always going to be our denominator. So for us, that's going to be x. So as you can see with this example, we had a measurement of time right here, hours. So from our helpful hints, we said if we have a measurement of time, it's going to be our denominator, and look where it went in my rate. It was on the bottom. So that's one way to help you out and kind of remember who goes where and how to set things up. Okay? And another helpful hint that I'm going to give you that's going to come in handy for our next example anything after the word per in your sentence is also going to be our denominator, or our x value. Because sometimes not every problem is talking about money or has a measurement of time, but most of them will have the word per, so that will help you know which one is x and which one is y. Okay, so we're going to do an example. And talk about the amount of deer that were observed per square mile. So as you can see here, we're talking about deer and miles. I don't have money and I don't have a measurement of time. But what I do have is the word per. And right behind that word per is square miles. So that tells me up here we said anything after the word per is going to be our denominator or our x value. So we're going to create a table based off of information from a word problem. And we now know that miles is going to be our x value because it came after the word per. That means deer is going to be our y value. Okay. So in a 16 square mile part of the forest, somebody saw 144 deer. In another part of the forest, over 13 miles, somebody saw 117 deer. And somewhere else, over a 24-mile span, somebody saw 216 deer. So we want to know the unit rate or the constant of proportionality. How many deer are there in 1 mile? So we follow our same equation that we've been doing, k equals y divided by x. Remember, this fraction line is just a division sign. So even though it looks like a fraction, all we're doing is dividing. And just like last week, we want to go through every part of our table. So we start with our first column here. Our y value, the deer, is 144 over the x, 16 miles. We would divide that top in, bottom out, and it gives us 9. Okay, then we check our second column in the table. Our y is 117 deer over x, 13 miles. And again, we would divide top in, bottom out. We would get 9. And our last row, our y value is 216 divided by our x value, 24. We would divide and get 9. Now, notice what happens here, here, and here. We got the same number every single time. So that means we can confidently say that our constant of proportionality, k, is 9. There are 9 deer for every 1 mile. And just like we pointed out last week, since I got that same number every time, we can say that the relationship is constant Therefore, we can also say it is proportional.